Today I'm going to talk about this ominous counting device, which just counts up to 99 on this display, and then resets itself and starts counting again. And this is for a project. I'll talk later about that. And well, the components are very simple. It just has 5 components really. It's got this ISP programming socket. It's got a microcontroller, which is a Atmega328, which is the microcontroller that's used in a lot of the Arduinos. But it's not running any kind of Arduino. It's just there and running the compiled C code. I fed it through this socket. It's got down here, which is maybe a bit hard to see, 2 resistors. Those go up from the microcontroller up to the 7-segment display, and then it's got just a mess of wires going back from the segments of the 7-segment display to the pins on this microcontroller. And I need this for a project where this is supposed to display a temperature that's read by a PT100 RTD resistive thermometer. And the idea with that is I'm going to build this in blocks. I'm going to do like the 7-segment display code, and I'm also going to do the preamp for the RTD, and in the end I'm going to stick it all together and maybe make a video about it. Probably going to make a video about it. So yeah, and the main subject of this video is actually the code that makes this work. What this does is it's multiplexing. So this microcontroller, it activates one segment and then punches out a number, and then it turns on the other segment and punches out that number. And that is why it looks a bit flickery here, because it uses persistence of vision, and there's always a bit tricky on camera, but if you look at it with the naked eye, it's not flickery. So yeah, there's not a lot to this electronically, but there is a lot of software to this, and I think we should go over this right now. So let's go over the code that makes this work. I'm going to do this probably top to bottom, with some slight jumps in between maybe. First I'll do is I'll just include 2 libraries, AVIO and until delay, to have the pins and ports conveniently labeled, and also to have a non-stupid delay. So then I'll just do a bit of config. I use port D and the data direction register for port D for my 7 segments, and I'm also using the whole port B and its data direction register for the multiplexing pins. This is something I'm going to change. This was just for testing to see how far I could push the whole thing. This setting the whole port B basically allows me to use up to 7 displays and 7 segment in multiplexing, which is entirely unrealistic on this controller, because of basically you're just refreshing the display all the time, and you're not even doing that great, and you don't have any time to do anything else in your program. So this works very well for up to 2, maybe maximum 3 displays stringed in series, without optimizing it further. Yeah. So next thing, I'm sort of defining myself 2 integers here, one called number and one called input number, and I'm going to use those in the code that's below and also in the main loop. Input number is basically the number that's, well, as the name says, input into the thing, and number is something that the two things down there basically work with, where I can shave something off and just sort of as a working number. So this is the main thing that's going to be called whenever the 7-segment display is fed a new number, and it's called with input number. And if input number is smaller, is larger than 9, it has 2 digits, and we have to do something to it. If it's smaller than 9 or equal to 9, then we can just turn on the first display down here and just display the thing. So that's what it does here. It's like input number is equal to number, turn on the first display, the one on the right, and then display the number out. If we've got 2 digits, it's slightly more involved. And what we do is we run through this loop, and this loop basically does the following things. It extracts the last digit using a modulo operation and writes the result into number. Then it turns on the first display, writes that number out, just waits a teeny tiny bit for it to be persistent, else you can't see a thing. Then it shaves off the last number, just dividing it by 10, and then it turns on the second display. By the way, these two I will change to something more sensible, that not a whole port is wasted, but that's something for later. Turns on the second display, then displays that number out, waits for a little while. So in this thing here called display, it's actually down here, what it does is what it says in the comment up here. It maps the number in number to the display in a somewhat crudish way. It just uses switch, case, and break to map it. Like in the case of 0, everything is on except for the middle segment, the segment number with the letter H. It's inverted here because this is a common anode display, so you've got to basically 0 means the segment is on, and 1 means the segment is off. You could easily adapt this to common cathode by just either changing this or basically inverting the number. Yeah, and it's very flexible in a way. You can also I might use this later on to also display hexadecimal. Then you just would need to write some more cases up here. Case for A, B, C, D, and so on. So yeah, and then the last thing down here is basically the main loop in the setup. The only thing that's done in the setup is just set the data direction registers, so everything is an output. Turn the segments off initially. This down here I don't even need anymore. This is from a previous iteration. This is not used at all. And then we do something down here. We just call this 7-segment thing with the input number, and then we increment the input number. If the input number is equal to 99, we set the input number to 0, and we'll just wait a while to simulate the processor doing something else, because it's not only to display a number, but this also, as said, should read an RTD later on, which is probably going to take some time, although 7 milliseconds is plenty for that. Yeah, and that's basically the code.